Hey everyone, today we're going to be talking about how you can solve quadratic equations by factoring. Before we do that, I do want to take a look at what this would look like graphically. And as you go through this video, please pause as needed, and I suggest that you give yourself an opportunity to try problems and then continue on. So kind of starting at the top of the notes here, filling in this blank, a zero of a function is what we're going to look at. Okay, so zero of a function is going to be the value of the input x that makes the output equal to 0. Okay? These are also called x-intercepts. Alright, so think about that in terms of an ordered pair. So whatever we input for x and we get 0 as y, that's going to be an x-intercept. And so graphically, it would be where the values cross the x-axis. So we've talked about graphs before. Anytime that we get 0 for the y, those are the x values, which are also considered our solutions. Some other things you might see them called, so our x coordinates are called zeros. They could be called roots and solutions. Those are kind of the usual terms that we use for these things. Okay, so if you ever see in the instructions to find the zeros, it means solve, and we should get an x equals for our answer. Okay. What's going to be important with this when we do have factoring equations is that you want to make sure that your equation is set equal to 0. Alright, so if the equation is currently not set to 0, which we'll look at an example here in a second, make sure that you do that first. You're going to be able to use any method you want. So in terms of factoring, that would mean you can either use guess and check, or you could use grouping. It's your choice. I'm going to do the majority of these by guess and check, but there will be at least one example that I do by grouping to show you that method. And again, when you're factoring, first thing you want to always look for, always, is a GCF. So if the problem does have a GCF, make sure that we factor that out. And we'll look specifically what we'll do when we're solving what to do with the GCF. Okay, so let's look at this first example here. So example 1 is x squared equals, negative 7x, and then minus 10. So in terms of steps, just like we wrote down a second ago, is you want to make sure that the equation is set equal to 0. So that would be the very first step, that if the equation is not currently set equal to 0, get the equation equal to 0. Okay, that has to happen. And the idea behind this too is that you want to keep the x squared term positive. So when we look at this, we've got x squared equals negative 7x minus 10. Suggestion would be to add 7x and 10 on each side to keep the x squared positive. So we've got x squared plus 7x plus 10 now equals 0. So some problems will already be set up this way, but if it's not, again, set it equal to 0. It's the very first step. Second step is now we're going to factor this left side. Okay, so factor would be next, and you can choose so factor by a method of your choice. So whether that be guess and check or grouping, that's completely fine. So I'm going to do, like I said, guess and check for the majority of these examples, but there will be at least one that I will do grouping for. So in this case, when A is 1, so we've got A is 1, B is 7, and C is 10, guess and check will be just a little bit easier. So two things that multiply to be x squared would be x and x. And two things that multiply to be 10 here, either 10 and 1 or 5 and 2. And the combination that's going to allow you to add to be 7 is going to be a positive 5 and a positive 2. Okay, so again, factor that side, and then the final step here is going to be to set each factor equal to 0 and then solve. Alright, so we've got two factors. We have x plus 5 and x plus 2. we're going to set the x plus 5 equal to 0 and the x plus 2 equal to 0, and we'll subtract here, getting x is equal to negative 5. Same idea, subtract here, getting x is equal to negative 2. So a good portion of these are going to have two answers. In this case, it's negative 5 and negative 2. Graphically, what that means is that these are the x-intercepts, and this is where the parabola would cross the x-axis, both at negative 5 and at negative 2. So the reason that we'll have two answers is this property that says if this value here is equal to 0, then the entire thing will cancel out. So let's plug it in. So negative 5 plus 5 is 0, and negative 5 plus 2 is negative 3. 0 times negative 3 is equal to 0, so that works. Same idea, negative 2 plus 5 was 3, and then negative 2 plus 2 is 0. So 3 times 0 is still 0. So that zero product property is what allows you to get two answers here. So negative 2 and negative 5. Okay, take a look at the next example. Alright, so I'm going to look at this x squared minus 49 equals 0. Reminder, we want to make sure it's equal to 0, which this is good. In terms of factoring, there is no GCF, so we're good with that as well. And again, when this is only two terms, think of what we talked about the other day in class. This is going to be a difference of squares problem, so DOS, difference of squares. Difference meaning subtraction, and both of these are perfect squares. Okay, so reminder that the pattern for a difference of squares problem is going to look very, very similar in terms of what's in the parentheses, except you have one positive and one negative. So if we look at this x squared minus 49, two things that are going to multiply to be negative 49 but cancel out are going to be a negative 7 and a positive 7. Okay? So we have, we made sure it's set equal to 0, we just factored, and then the next step again is to set each factor equal to 0. So x minus 7 equals 0, x plus 7 equals 0. We'll add 7 here to get positive 7, and subtract 7 on this side to get negative 7. And so you can list it out as positive, comma, and then negative. Or when you have the same value but just opposite signs, you have an option to also say x equals plus or minus 7. That's something we'll see a little bit more of here in the coming units, but so you can list it out individually as positive and negative, or you can use that symbol for plus or minus. Okay? Next one, 2x squared minus 11x plus 12. Again, it already equals 0, so we're good for that. What's a little bit different here is that a is not 1, so I am going to do grouping for this particular example. So remember, first step in grouping is to take whatever's in front here, which is the 2, multiplied by the constant, so a times c. So we'll get 2 times 12, which is equal to 24. And so we're trying to figure out a combination of two things that are going to multiply to be 24 and then add to be negative 11. Okay, so we need two numbers multiply to be positive, add to be negative. We need both of these values to be negative. So we've got negative 2 and negative 12, negative 24 and negative 1, negative 4 and negative 6, negative 8 and negative 3, and that's pretty much all the combinations. I don't think I missed any. But if we add these two up, negative 12 and negative 2, when you add them is negative 14. Again, we need it to be negative 11, so that doesn't work. That's going to give you negative 25. That would give you negative 10. And this here, negative 8 and negative 3, does give you negative 11. So this is the combination that we would need if we're going to do grouping. All right. So negative 8 and negative 3 is the correct combination. So I'm going to rewrite our trinomial. So we've got x squared, negative 11x. Again, I'm going to split apart to be negative 8x and negative 3x, and then plus 12. Now the grouping portion of this, we figure out a GCF between those two terms and a GCF between those two terms. So between the 2x squared and the negative 8x, we can take out a 2x, leaving you with x minus 4. And same idea here between the negative 3x and the positive 12, we're going to take out a negative 3, and that would leave you again with x minus 4. So we have this x minus 4 in common. We'll write that one time because you're basically factoring that out from those terms. And once we've written that x minus 4, we have this 2x minus 3 left over, which goes in the second set of parentheses. Okay, and remember we are solving, so we need to set each of these equal to 0. So if we have x minus 4 equals 0 and 2x minus 3 equals 0, here we can add 4 and we get positive 4. Over here we'll add 3 and then we can divide by 2. And so we've got our two answers of positive 4 and then positive 3/2. And again, that's where the graph would cross the x-axis, positive 4 and then positive 3/2, so 1.5. Okay? All right, last two examples I want to look at are what if there's a GCF? Okay, so we're going to treat this very similarly to when we were factoring. Okay, so first step, though, we want to make sure we get this equal to 0. So we've got 2x squared minus 4x, and we'd have to subtract 30 on each side to get minus 30 equals 0. If you notice here, we can take a 2 out of all of these things, and so that's what we're talking about in numerical GCF, meaning there's a number that each value has in common. So what I'm going to do, take the 2 out and write it on the outside here. So we have 2 times x squared minus 2x, and now minus 15 is equal to 0. And let's go ahead and keep factoring, and I'm going to do guess and check here. Two things to multiply to be x squared would be x and x. Multiplies to be negative 15, and then adds to be negative 2, negative 5, and positive 3. Okay? So now, what we want to do is set each factor equal to 0, and so the factors are going to be where the variables are. So this x minus 5 will set equal to 0, and the x plus 3 will set equal to 0. We do not need to set the 2 equal to 0. So essentially what we're doing is basically we are dividing this entire thing by 2 and just getting x minus 5 times x plus 3 equals 0. So when you are solving, the GCF isn't important, but when you are factoring, you have to leave the GCF there. Okay, so if we finish out this problem, we're going to get x is equal to 5, and then over here we'll get x is equal to negative 3. So again, the 2 doesn't matter for the zeros here. It just matters in the factoring portion of it. Okay? And then final example is if we have a GCF and there's a variable. Okay, so a little bit different. Over here again, it was just the number. Here we have a variable. And so we've got this x squared minus 8x. This is only 2 terms. It is missing the c value. It's already set equal to 0. And so we want to factor out the GCF in between x squared and 8x, or negative 8x. It's just x. So we take out the x, and we'll have left x minus 8. Okay. So again, anywhere there is a variable, we need to set that portion equal to 0. So we have that we can set equal to 0, the x in front, and then we also have the x minus 8. So here there's nothing to add or subtract. So 0 is one of the zeros for the problem, and then the other solution would be positive 8. So that means that this graph is going to cross through the origin and then also through positive 8 for its solutions.